key is realizing that when we are using this particular formula, notice it's saying we have got to be in radians. And if we're not, we've got to convert so that we are in radians. Okay, so, but we're just plugging into this formula. So S is arc length, R is the radius, theta is our angle, and that has to be written out in radians. There are going to be two formats that I'm going to ask for the answer. So let's look at some examples of how this works. It says, circle has a radius of 25.6 centimeters. Find the length of the arc intercepted by a central angle having each of the following measures. So if we have an angle of 7 pi over 8, then that means we are plugging in and we are doing S is equal to R, which we know is 25.6, times theta, which in this case is this 7 pi over 8. Okay, so for our exact answer, we truly just want to multiply and get that number. It might be written as a fraction. It might be, in this case, because of that 25.6, we're just going to multiply 25.6 times 7 divided by 8. We get that decimal. So that is, what, 22.4 pi. Please do not forget to include the units as well. So 22.4 centimeters. So that would be considered our exact answer. And then to get the approximate answer, you are truly going to plug in and use that pi key, which bottom left somewhere. I never remember exactly where it is, but it's in the bottom left. So if you do 22.4 times pi and get that decimal, it looks like you should get about 70.37 centimeters. Try that and check and make sure. Yes, good. Thank you. Okay. What do we need to do for part B first? We're given degrees, so what have we got to do? Yeah, we've got to convert that to radians, so let's do that first thing. So 144 degrees is equal to what in radians? Maya, what'd you get? Huh? We're degrees, remember we divide by 180 and we add the pi. Yep, there you go, 4 pi over 5. Okay, so then when we are plugging in to get our arc length, we are doing radius, which they said is 25.6 times that 4 pi over 5. And we're in centimeters again. So let's just plug it in for this. So 25.6 times 4 divided by 5, we get 20.48 pi centimeters. And then if you plug in and do 20.48 times pi, you get the decimal approximation, and that will be 64.34 centimeters. Okay. So pretty straightforward in terms of plugging into the formula. There are times, if you look at this next example, we're kind of working backwards, right? We're given the S and we're given the theta, so we're solving for R, right? So let's plug in. So S is equal to R theta, so S in this case is 3 pi equals R times pi over 2. So if we're trying to solve for R, in this case we would need to multiply by 2 over pi, right? And then that would divide out, so then we get what R is equal to. The pi's will divide out, and we just get that R is equal to 6. Okay. So sometimes you're working backwards on those, but pretty straightforward, all right? Okay. For arc length, again, if you notice, we're not going to solve these two, but just a reminder, how do we deal with this, right? If you need to or want to do some more practice, you can, but you're going to get practice with some of the other stuff. on this one, the main concern would be remembering to switch that. So 125 degrees, when we convert that, what do we get? In radians. 25 pi over 36. There we go. Thanks, Kylie. Okay. So it's just more of just kind of straight plugging in, right? I'm not going to go through all of those. Let's look at the area of a sector now, that formula. So this formula is a little more involved. A is standing for the area. And then our R, once again, is our radius. And theta is our angle, right? And once again, it must be in radians. So if it is not, you're going to have to convert. So on this first example, we definitely have to convert. So 108 degrees in radians. CJ, what is that equal to?
What is it,
108, yep.
It's 3 pi over 5.
3 pi over 5. There we go. Okay, so we are, let's see, to plug in and find the area, we're doing 1/2 times 15.2 squared times 3 pi over 5. You do have to be a little more careful in plugging in on your calculator for that. Let's see, what do I get here? For exact answer, we get 69.312 pi feet squared. And then if you go in and plug in the value for pi, you get that it's approximately 217.75 feet squared. So check, make sure you can plug in correctly. People tend to forget, if they make mistakes with the plugging in, it has to do with either the squaring usually or dividing by what's in that denominator. So just be careful plugging in, okay? All right, questions on that formula? Okay, try these next two here. Try A and B. Talk to a neighbor if you need to. We'll go over those in just a second.
Can you bring it back up a little bit?
Yep. What do you need? We are not going to do all of these on this page. We're not doing the top two, but we are going. I do want to talk you through. There's just kind of some. Thank you. Okay, there's kind of on a couple of these, there's some extra steps or some extra things that you have to be conscious of when you're working on these. This one, not so much. It says find the length of the arc to 3 places after the decimal. So that's giving you a hint that in this case, what the directions are saying is it only wants the approximate answer, right? So we're doing arc length, so that's this formula, right? So we're plugging in 1.38 times 5 pi over 6, excuse me. So then you're just plugging that in. So 1.38 times 5 times pi, all divided by 6. What does that give us? We're going 3 places after the decimal. What do we get on that, John?
Got 3.61.
3.6. I got a little bit different answer than that. You got 3.65?
3.61.
All right, help me out. I might have a mistake written on here. I had it written as 3.6128, so it would be 3.613.
Yeah.
Okay. All right. You good? Yes? Okay. All right, questions on that one? Guys, please don't forget units. And arc length is just gonna be feet or inches or whatever. If it's the area formula, then you're dealing with squared units, right? Okay. Find the area of the sector. You need to notice what you are given here. So ultimately, we know we need to use this formula. But I need you to think about what we're given. If you notice, we're given that r is 6, and we're given that the arc length, which is s, is 2 pi. But we don't know what theta is equal to. So the directions are asking you to just find the area, but in this case, you have to use both formulas. You have to use your arc length formula first and figure out what theta is equal to, and then you can go back and plug in. So let's plug into the s equals r theta first, and let's plug in. So we get 2 pi equals 6 theta. So if we divide by 6, we get that theta is pi over 3. So now we can plug into our area formula. So just please realize, be conscious of this, that just because you're asked for area, you might not be able to go straight to that area formula. You might have to do some other figuring first. Okay, so to find area, we're doing 1/2 times 36 over 1 times pi over 3. So 36 pi over 6, in other words, we get 6 pi. There's no units given, so let's just put a unit squared to help us remember we need to have those squared units. And then that is approximately 18.85 units squared. Okay. All right, let's take a look at this one. We're finding area of a sector again. What are we given? Sam, what's one piece of information we're given? Okay, so radius is 12. What else are we given? Sophia, what's that other? The 12 pi, what is that? Okay, so that's our S. So that's 12 pi. So once again, we're having to figure out what theta is, right? So 12 pi equals 12 theta. So theta is equal to pi. And now, yikes, now we can plug into that formula. So A is equal to 1/2 r squared, so that's going to be 144 times pi. So half of 144, so 72 pi, and we don't have units again, so units squared, and that's approximately 226.195 units squared. So that one, once again, that was very similar to that last one where you were having to use the first formula before you could use the area formula. Okay, questions on either of those? Okay, last one here. So it says find the central angle. So we're finding theta. We're given what the area is. So think about your formula. A is equal to 1/2 r squared theta. So let's plug in what we're given. So 36 pi is equal to 1/2 times 6 squared, which is 36 theta. So we get 36 pi is equal to 18 theta. If we divide by the 18, we get that theta is equal to 2 pi. So clearly that drawing is not drawn to scale. Right? So kind of working backwards on that one, right? We're not gonna really solve through any of those on that next page, on page 32. I'm gonna keep those there as review or practice if you need them, but there is one thing that I wanna do. There are a couple of these problems that you would have to do a little bit of extra work first. You'd have to do some converting, so let's put that note in there. So I see 2 up here that you'd have to convert. So that 125 degrees, what is that in radians? Dina, what do we get for that? Okay, so 25 pi over 36. And here, that 147 degrees, Alex, what do we get? Okay, good, 49 pi over 60. Great, okay, I'm seeing degrees on the left, radians on the right. Okay, Vivian, what do we get for the 80 degrees? When we convert that? Baratalias. Okay, so 4 pi over 9, there you go. And last one, Zach, 225 degrees is? 5 pi over 4. Beautiful. Okay, so that's kind of a good reminder here. You may want to even just put a little note, convert degrees to radians. That might be the best reminder you can get to see that whole page where all we've done is just convert from degrees to radians there, right? Okay. The homework is those next 2 pages. If you look, it's pages 33 and 34. I do want to kind of talk you through. I want you to notice some of the directions are kind of telling you what you should do in each section, so be conscious of that. So let's take a look.